Hello, everyone. All right, let's solve this Maths Olympiad question. All right, so we want to calculate the area of this region. That's the one labeled with letter M. All right, so we have the length of this line, this side, this. Now we are given a right triangle. That is, we have a semicircle inscribed in a what? In a right triangle, A, B, C. Okay, now one of the legs of the right triangle is what we have as 6 meters. So the length of the other leg, okay, is not given. The other leg of the right triangle is not given, but we are giving the that's side A, that we are giving this side AD to be 2 meters. D is what is a point where the semicircle and what and the right triangle where that's where the semicircle touches the right triangle. So we have that to be 2 meters. So we want to calculate the area of the shaded region M. Now let's have our solution. Okay, now this is the radius. Okay, radius is the length of the line joining the center of a circle or a semicircle to its what? Circumference. So which means now from the center, when a line is joining the center of a circle or semicircle to its circumference, then it will be called radius. All right. Now let's say again, I decide to draw another line from the same center so that it touches the point of contact between the semicircle and the what? The right triangle. So we are also going to what? Have that as what? Radius R. All right. So when a line from the center of a circle, okay, is drawn to pass through the point of intersection between the point of contact between a tangent and a what? A circle or a semicircle, then that line is what we call radius. Now, it's a theorem. It's one of the theorems in circle theorem, okay, that when a line is drawn from the center of a circle, all right, to pass through the point of contact between the external part of the circle and the tangent to the circle, then that line will be called, it will be what? Radius. And the radius will make an angle what? 90 degrees. Okay, it will make angle 90 degrees, okay, with the what? The horizontal. So which means that in this case, we now have another right triangle. So let's say we have this side of the right triangle, this leg of the right, the leg of this leg of the right triangle, the new right triangle to be ME. Okay, so let me bring out. So we now have two right triangles. Now we have the small right triangle. Okay, we have the small right triangle A. We have AEM. All right, we have AEM, which is what we have here as we have AEM. Okay, so this is M, and then this is what? E. Now this is what? This side is what? R, and we have an angle of what? 90 degrees. Okay, so now in this case, now again we know that joining the center of a circle to its circumference is what? Radius. So which means DM, okay, DM will now become what? Will now be R. That means DM, okay, is also what? A radius. So that means it's a radius. It's what? It's a radius. Okay, so which means MC will also be what? Will also be what? Radius. So in this case, so when we say MA or AM, so which means we're considering AD and DM, and that will be what? So we're going to have that to be 2 plus R. So the side, now the length of side AM, okay, will be 2 plus R. Okay, now the big right triangle, now let's consider the big right triangle ACB. Now we have ACB, which is the big right triangle. So for the big right triangle, we have this, okay, this is what it looks like. So this is the big right triangle. This is C, this is A, and then this is what? B. Now I said they are similar shape. They are similar shape. Now both triangles are, they are right triangle. Both triangles are right triangle. Now they have a point in common. Now look at A. The same A we have for ACB is what we have for what? AM, that's AEM. All right. So let's consider that. Let's say we have a small angular measure, all right, at A. Let's say we label that as what? As theta. So we are going to have the same angle, okay, for right triangle ACB. So which means they have what? They have that means whatever we have here as angle theta is the same as what we have here for the big right triangle ACB. All right. So now, because we are not giving this side, so let's side AE equals to x. So this side will be what? X. So when we know side AE to be x, now we can now consider, the relationship between, R and X, because we've been able to identify, okay, to identify why these two angles, okay, will be the same. So if I consider this angle at A, so I will have sine of angle theta. I want to find out the relationship between R, this side of the triangle, opposite over hypotenuse. So that will be R over what? 2 plus R. So I'm going to call this my what? My first equation. This is equation 1. R over 2 plus R, opposite over hypotenuse. Now again, when we look at this other triangle, now we have here that we have this side to be 6 meters. So from C, okay, to B, or side BC is what? 6 meters. So because we know the side BC to be 6 meters, and then we want to what? We want to use the same trigonometric, identity in this case. Now, I have, this is, the side opposite the given angle is what we call opposite. So this leg, now this side of the right triangle is opposite this angle. So if we consider using sine theta, because these two triangles are similar. All right, so we now again consider the fact that, okay, this is the length of side EB. Now to find out the length of side EB, now we're going to what? Apply, one of the theorems in circle theorem. And the theorem, okay, the theorem is the one that talks about when we have two tangents, okay, two tangents to a circle, which intersect, okay, which intersect at a point external to the circle, are equal in length. They are equal in length. So now we have a circle, then we have two tangents, to the circle meeting at a point external to the circle. Okay, for those of us that we know about the theorem, some of the theorems in circle theorem, okay, we know that when we join the tangent to the center, okay, so we know that this will be a radius. This will also be what? A radius. So, but what we need here is that, okay, let's say this is A and then this is B, okay? So, and we have, they meet at the same, they meet at a point external to the circle, and that is what? E. So the length of AE, that's the side length AE, will be equals to side length what? BE. So that means they are equal in length. So that's exactly what we're going to apply here. So this is a tangent. This is a tangent. And this is a tangent as well. So which means that EB, all right, the length of side EB, okay, would be what? Would be 6 meters. So by the time we now add 6 meters to, when we add 6 to AE, because we know that AB, side AB, okay, side AB would be AE, okay, plus EB, So we then have AB to be equals to X plus 6. So which means x plus 6 is what we have as the length of side AB. Remember, we want to what? We're going to find out the value of x. All right, so in this case, so we apply this theorem for us to what? Know the side BE. And we have our side BE to be what? 6 meters. And we know that BE plus AE will be equals to what? AB. And that's what we have here as x plus 6. So if we use SOHCAHTOA and we find out the sine of this angle, we're going to have, this is the opposite. Remember I said the side which is directly opposite the angle given is what we call the opposite side. Okay, the hypotenuse is the longest side of a right triangle, and it is the side opposite angle what? 90 degrees. So in this case, we have opposite over hypotenuse. So the opposite will be 6. Then the hypotenuse will be what we now have as what? X plus 6. Okay, so remember, this is a theorem in circle theorem. Okay, so we have 6 over x plus 6. 6 over x plus 6. So this now becomes equation 2. Now we know that these two triangles, they are similar. And one of the reasons why they are similar is because they have the same angular measure at A. All right. So, and now when we find out, when we write the ratio for sine theta, okay, for when we consider the smaller right triangle or the small right triangle, what we have is r over what? 2 plus r. And when we write the ratio for sine theta for the big right triangle, then what we have is 6 over what? X plus 6. So we can now equate. We can now what? Write equation 1 to be equals to equation 2. So we have equation 1, okay, equals to equation 2. Now we know that equation 1 is r over what? R plus 2. While equation 2 is what? 6 over what? X plus 6. All right. So now in this case, it could be one of two things. All right. Now we need to what? Express either x in terms of r or r in terms of x. Now don't forget that now our goal here, okay, because remember we want to find out, we want to calculate the area of the smaller, of this what? Of the shaded region. So to be able to calculate the area of this region, now what we can see here is a sector. We have a sector, and then we have a right triangle. Okay, so that means to be able to calculate the area of the shaded region, okay, we need the value of r. So to be able to calculate the value of r, so we need to what? Consider the fact that when we drop a line from the center to touch or to pass through the point where the tangent to the semicircle, okay, where they meet, okay, that line will be what? Radius, and it will make angle 90 degrees with the what? With the horizontal. So in this case, when we cross multiply, in this case, we're going to have r into x plus 6 equals to 6 into r plus 2. Now let's distribute r in this case. So we have rx plus 6r. When we distribute 6 in this case, we have 6r plus 12. So 6r will cancel out. Then we'll be left with what? Rx equals to 12. Like I said, we're going to express any one of these two in terms of the other. So now I can write, I can leave my r to be equals to, r will be equals to 12 over what? X. Now, this is our new equation. Let's call this equation 3. Now, we have r to be equals to 12 over x. Okay, we have r to be equals to 12 over x. Now, remember, we want to find out the value of r because now our first goal is how can we find the value of r. So when we know the value for r, then it makes the work easier. Okay, so to be able to find the value of r, now we can see here that in this, now we have for the small right triangle, we have this side to be r, and this is what? 2 plus r, and this third side is what? X. And we have our relationship between, that is r expressed in terms of x to be what? R equals to 12 over x. So what we're going to do in this case is to what? to write the equation, okay, connecting these three sides using the Pythagoras theorem. Now, we have when we consider the right triangle AEM, okay, so we know that by Pythagoras theorem, we use the Pythagoras theorem. All right, so we're going to have the hypotenuse. The hypotenuse is what? 2 plus r, and we raise that to the power of 2 because hypotenuse square equals to adjacent square, okay, plus opposite square is Pythagoras theorem, and this will be equals to the adjacent is what? X, so that will be x raised to the power of 2, then plus r raised to the power of 2. So we can what? Let's obtain the that's the identity for square of r plus 2. So the expansion for this will be 4 plus 4r plus r square equals to x square plus r square. Now r square will be eliminated from both sides, so that the equation can now reduce to 4, okay, plus 4r equals to x square, Now, don't forget that we have here that r is equals to what? 12 over x. Now I can replace x, I can rewrite this equation so that we can have x in terms of r. Yes, we can have x in terms of r. So we know that from here, okay, we can have x, okay, we can have x to be equals to 12 over r. So I'm going to what? I'm going to substitute for x in this equation. So I have here 4 plus 4r equals to 12 over what? R raised to the power of what? Raised to the power of 2. So what we have done here is what? We substitute for x. Substitute for x. All right. Okay. Now, we have 4 plus 4r equals to r squared over r. So when we square 12, that will be 144. And when we square r, that will be r raised to the power of 2. So we now have 4 plus 4r equals to 144 over r squared. When we multiply this equation, when we multiply by r squared, we're going to have 4r squared plus, 4r squared multiplied by 4r. That will be 4r cubed, okay? Now, when we multiply 144 by, when we multiply r squared by 144 over what? R squared, then this will become 144. All right, so now here we have 4r squared plus 4r cubed equals to 44. Now we can reduce this equation. Now we can also reduce this by dividing the equation by what? 4. So when we divide this equation by 4, this will reduce to r squared plus r cubed equals to, so 144 divided by 4, that will be 36. All right, so this will be 36. Yeah, that will be 36. Now, so we have the sum of square, and we have square of r, okay, plus cube of r equals to 36. Now, then we can bring this in, we can move to 36 to the left hand side, so that the equation can be r squared plus r cubed negative 36 equals to 0. All right. Now, can we solve equation like this? Is it possible to be able to solve equation like this? The answer is yes, it's possible, but it will require it will require your ability to think out. Like now we have square of r plus cube of r minus 36 equals to 0. So we have now, that means to be able to get the value for r in this case, we now have to think of a cube number and a square number, that which when added together will give us what? 36. I repeat again, a cube number and a square number that when added together will get what? 36. And they will have a value in common. That's this cube number and the square number, they will have the same base. Now, in this case, we have r squared, okay, now plus r cubed minus now for now 36, that'll be 27 and 27 and 9. Yeah, that'll be, so we're going to have negative 9, okay, minus 27. Yeah, and that will be equals to 0. So this will be r squared minus 9 plus r cubed minus what? 27, and that's equals to 0. Now, here we have r squared minus 9, and here we have r cubed minus 27. Now, like I said, 27 is a cube number. 9 is a what? Is a square number. So we can write this as difference between two squares, or difference of two squares. And we know that the exponential representation for 9 will be what? 3 raised to the power of 2. So this will be r squared minus 3 squared plus r cubed negative what? 3 raised to the power of 3. Raised to the power, now raised to the power of 3 equals to 0. Now we have difference of two squares, and we know that for difference of two squares, let's say we have a square minus b square. This will be a minus b, then a plus b. So we are going to write r square minus 3 square in as what? That's in terms of this. So then we also have a cube minus b cube. That will be a minus b, okay, bracket a minus b, then a square, bracket a square plus ab plus b square. All right, so that's for difference of two squares and difference of two cubes. Okay, this one is for difference, okay, of two cubes. Difference of two cubes. All right, so now, so we are going to apply that here. So we have, this will be r minus 3, okay, r plus 3, then plus r minus 3, which is according to this, bracket r square plus 3r plus 9, okay, and then we set that equals to what? 0. So we can factor out r minus 3. So we have r minus 3 to be equals to 0, or we can also have r plus 3, okay, we have r plus 3, then plus r squared plus 3r plus 9 equals to 0. Okay, you know, normally when we factor out r minus 3, we're going to have r plus 3 plus r squared plus 3r plus 9. So that's it. So now we have here that r will be equals to what? 3 meters. So we've been able to get the value of r. Now here we're going to have r squared plus 4r plus 9 equals to 0. And in this case, are we going to get 3, or are we going to get real root or a complex root? The answer is that we're going to get what? A complex root. Okay, yes, we're going to get a complex root. That's, for instance, we use b squared negative 4ac. Okay, now we know that this is going to be, b is 4, so 4 squared negative, now 4 times 1 times 9. Now this is going to be 16, okay, 16 negative 36, which will be what? Negative 9. So that's negative 30, that will be negative 20, okay, negative 20, okay. So which means that b squared, when we use discriminant here to find out or to check whether or not we can get a real root, then this will now with what we have here, then this is not going to work. So the value of r will be 3 meters. The value of r will be 3 meters. So now, having found the value of r, now let's come back to what we have here. Okay, now I'm going to be needing the smaller right triangle. I'm not going to use the bigger right triangle again. Okay, so what we have here is, now we now have the value of r to be what? 3 meters. We have the value of r to be 3 meters. So which means when we add 2 and then the value of r, so we're going to get the side AM to be equals to 5. Now we know that side ME, okay, side EM is now what? Is now 3 meters. So which means if we apply the Pythagoras triple, so we're going to have AE, side AE to be equals to what? 4. So now, which means that the right triangle will now have side AE to be 4, side AM to be 5, and side EM to be what? To be 3. So we have 3, 4, 5 using Pythagoras triple. So now, so in this case, remember, we want to obtain the value of, we want to find out the, what's it called? We want to find out the, now this is what we have here, okay? Now we want to find out what is the area of this smaller, of this small portion here, okay? But we need this angle. So when we know this angle, then with this angle, we'll be able to find the angle, you know, the central angle. And the central angle is the angle which the sector or which this arc subtends at the center. So let's get the value of this angle. So to get the value of this angle, now we know that we can recall that sine theta is what? Opposite over hypotenuse, which is 3 over 5. So we can now have the value of theta to be inverse sine of 0.6. Yeah, what is the inverse sine of 0.6? All right, so now the inverse sine of 0.6 would be 36.87. So that would be 36, okay, 0.87. Now we now know the value of this angle. So let's say this angle is what we have as alpha. So to calculate the angular measure, the size of angle alpha, it will now be 180 because the sum of angles in a triangle is what? 180. Now this angle is 90 degrees. So we have 180 minus 90, then minus this angle, which is what? 36.87. 36.87. Okay, so when we subtract, okay, from 180, when we subtract from 180, that is 180 minus 90, okay, minus 90 minus 36.87. All right, so this will be 53.13. So the value will be 53.13. So we now have the value, the size of angle what? Alpha to be 53.13. So to be able to calculate the area of the shaded region, okay, labeled with letter M. Now we have the angle which this arc, you know, subtends at the center, okay, or the angle of the sector. So we know that to calculate the area of the shaded portion. Now, to calculate the area of the shaded portion, now area of the shaded region M will be equals to area of triangle, okay, minus area of sector. Yes, area of triangle minus area of sector. So now let's get the area of the triangle. We know that area of triangle is 1/2 times base times height. So the base of the triangle is what? X. Remember, the base of the triangle is X. The height of the triangle is what? Is the radius. And we know that X is what? 4. X is 4. Okay? X equals to 4. Then the radius is what? 3. So what we have here will be area of triangle equals to 1/2 times the base, which is 4, multiplied by the height, which is 3. 2 out of 4, that will be 2. So 2 times 3, that will be 6 square meters, which is the area of the triangle. Now, the area of the sector. So now we know that the angle of the sector is what? Alpha. So that will be alpha over 360 multiplied by area of the what? Area of the, and that's area of circle. That's what we have as area of sector. Remember, it is area of circle we're going to use in this case. Okay, that's area of, now so to calculate the area of sector, because we know that the area of sector depends on what fraction of the whole circle the sector is, and the sector will be related to the central angle. So in this case, so we have area of the sector to be this value 53. Okay, we have 53.13 divided by 360 multiply by 3.14. Please don't forget the value of pi is the what? 3.14 multiplied by 3 raised to the power of 2. Okay, 3 raised to the power of 2. Now let's get the value. So what is 53.13 divided by 360? Okay, 53.13 divided by 360. All right, that will be 0.1475. Okay, we have 0.1476 multiplied by 3.14, okay, multiplied by 9. Okay, so we multiply by 3.14, then multiply by what? 9. That will be 4.17. So the area of the sector is 4.17 square meters. So we have the area of the triangle. So area of the shaded region will be the area of the what? Triangle minus area of the sector. Okay, so we have the area of the shaded region to be 6 square meters minus 4.17 square meters. So what is 6 minus 4.17? Okay, that will be 1.83. So we have 1.83 square meters. So therefore, the area of the region M is 1.83 square meters. The area of the region M is 1.83 square meters. The noblest pleasure is the joy of understanding. Bye-bye.